In this episode, we discuss the first principles of smart manufacturing. My guest on this episode is Conrad Leiva. Conrad is the VP of Ecosystem and Workforce Development at CESMII, the Smart Manufacturing Institute. In his role, Conrad is accelerating smart manufacturing adoption and education programs through a national ecosystem of regional centers, technology partnerships, and education institutions. A recognized industry authority, he engages manufacturing business leaders, educators, and practitioners across all dimensions of industry to develop and share knowledge on both the how and why to leverage information technology in manufacturing. Conrad is also the chair of the Smart Manufacturing Working Group at Mesa International, and he has over 20 years of experience in manufacturing systems development and implementation. And he holds an MS in Industrial Engineering from the Georgia Institute of Technology. A quick thank you to our sponsors. This episode is made possible by our friends at HiveMQ, who are providers of an enterprise-grade, edge, and cloud-based MQTT broker. So please do check them out to help support this podcast. Welcome to the Fourth Generation podcast here on Industry4.TV, which is a series of weekly interviews designed to help you learn industrial IoT from some of the world's leading practitioners. So if you're new here, please do subscribe and click on the notification bell to make sure that you never miss any of the interviews. If you find this conversation interesting, please review it with 5 stars on Apple Podcasts, follow on Spotify, and you can also connect with me on LinkedIn at Kudzai Manditereza. Now, here is my interview with Conrad. So, Conrad, I would like to welcome you and thank you so much for joining us today.
Thank you. Thank you. It's
yes.
Great to be here discussing important topics.
Awesome. Yeah, so today I would like to talk to you about the first principles of smart manufacturing, which is based off of your article that you published recently. So I'm going to link that in the description for our viewers to and listeners to check out. So
yeah, thank you.
You are the VP of Ecosystem and Workforce Education at an organization called CESMII. So maybe you can begin by giving us an introduction into CESMII. What is it and what does it do?
Yeah, so CESMII, the Clean Energy Smart Manufacturing Innovation Institute. It's quite a mouthful, but it's one of 17 Manufacturing USA institutes funded by the U.S. government to promote manufacturing technologies and advance the technologies in manufacturing, and each one in the U.S. focus on the U.S. and each one is focused on different technologies. One is robotics, one is additive, and CESMII is the Smart Manufacturing Institute, and it was funded in 2017 with a mission to democratize smart manufacturing, meaning making smart manufacturing methodologies and technologies more affordable and accessible to small and medium manufacturers. We do that through technology projects and also through education and workforce development. We have over 150 members, and they span from manufacturers to system integrators, technology vendors, and educators. So it's a great ecosystem, and a lot of what we do is match people together to work on projects and move the smart manufacturing agenda forward.
Interesting. So the concept of smart manufacturing has been around for quite some time. However, in my interactions with the community, I see that there is a lot of organizations and professionals who still do not have a clear picture of what it's all about. So could you give us a definition of smart manufacturing, perhaps by giving us a brief history of how it all came to be?
Yeah. So your point is very important. And one of the first things we did at CESMII was we need to define smart manufacturing clearly for everybody, because it tends to be viewed sometimes as an umbrella over everything. But we have actually a very specific agenda for smart manufacturing that has evolved over the years, like you said. So it actually, this journey started around 2005, 2006, when advances in connectivity, data handling, and computing power were really led to the term cyber infrastructure. And industry leaders started getting together and looking at what they could do with the cyber infrastructure and how they could improve manufacturing operations. In 2006, the term smart plant and smart process manufacturing were actually coined out of a report of one of these gatherings that was done by the National Science Foundation on cyber infrastructure for industry. So the thought leaders there were already thinking, okay, let's define what a smart plant looks like and what smart process manufacturing look like. And soon after that, a group was formed, the Smart Manufacturing Leadership Coalition, bringing together manufacturers, engineers, academics. And in 2011, they published a vision for smart manufacturing, which really led the roadmap here for smart manufacturing. And in parallel, in Germany, for example, they were starting to work on Industry 4.0 concepts around that time. And some of those early works actually referred to the smart factory concept also, but they settled on Industry 4.0. And in 2014, they published a roadmap. And that initiative, and what was unique about the German industry is that it was really driven by government because they saw the importance of manufacturing to their economy. All the machine builders and they have a lot of industry and economic growth around this industry. So soon after, the US in 2016 funds CESMII, the Smart Manufacturing Institute. And in 2017, we published the CESMII roadmap. And many of the industry leaders actually that started their work at the Smart Manufacturing Leadership Coalition are still here at CESMII in this ecosystem, helping move the agenda forward and helping others in their journey to smart manufacturing.
Okay, so that's very interesting. So what I'll do here is I'll read your definition of smart manufacturing from the article. So it says, smart manufacturing is the information-driven, event-driven, efficient, and collaborative orchestration of business, physical, and digital processes within plants, factories, and across the entire value chain. Now, there are some interesting key terms in that definition that I would like you to unpack for us. For example, we've got information-driven, event-driven, efficient, and collaborative orchestration. Yeah. What do you mean by those terms in the context of manufacturing?
Yeah, and this we went through a lot of iterations of this and carefully picked some of these terms and still try to do it in plain English is tough, right? But information driven is very key, right? And it's always been part of all these. So we took a lot of the terms that have been kicked around and as part of those goals and visions over the last years and say, okay, let's focus on what most people mean by smart manufacturing. And information driven means that we're basing our decision making on data. It's information driven, and it's not just we picked information instead of data driven because we want to talk about data with contextual information, and information modeling all is very key to smart manufacturing. Event driven, that is a nod to the real-time nature of smart manufacturing, that we want It's as things happen, as events happen, we need to react to them and act to them. So we can't be driving manufacturing through the rear window, the rear view mirror. So efficient, because why are we doing all these things? Because we want to do things more efficiently. Increase performance and productivity are a big part of smart manufacturing. And collaborative, because we're bringing down the silos, the walls between departments, and starting with the IT, OT wall that has existed in manufacturing for many years. And the walls between business, physical, and digital processes. So we used to be, business systems over here, our physical plans over here, and we're driven all through paper. And when part of putting this digital infrastructure in place is to bring it all closer together, and that everybody has visibility to what the other person handovers are better within the plants, factories, and into the supply chain.
Oh, nice. So what I would like us to focus on now is the 7 principles of smart manufacturing. You define these as principles that are required to establish a goalpost for smart manufacturing, and that by following these principles, systems designers and architects will be able to implement solutions that thrive in smart manufacturing. Now, one of those principles is flat and real time. Could you describe that principle for us?
Yeah, so we went beyond. So the definition kind of defines the what smart manufacturing is, and then we said we got to go beyond that. We have to start drilling into the how, and set these guiding principles, because there's been because we figured out that we realized that if we keep implementing systems the way we've been doing it for the last decade, that there's been a lot of creating islands of information and fragile integrations and systems that are hard to upgrade and become a lock-in for manufacturers. So they become a constraint to innovation. So we said, let's sit down and put these principles together and explain them, and explain how they help really future-proof your systems. And like you mentioned, one of the first ones is flat and real time. So as I said before, event-driven, right? We want to make sure that things happen immediately. And by the way, there's a lot of close relationship between these these principles, and sometimes it's hard to talk about one without mentioning the other. So that might happen during the discussion. But let's talk about the flatness, right? But there's a relationship. There is a history of plants being very hierarchical, of organizational structures being hierarchical. By the way, these are not strictly just systems architecture principles. They also are organizational structure or principles, right? This is where we're bringing the physical and the digital together, right? So we want to enable distributed decision making, more real time, empower more decision locally, closer to the machine, closer to the cell. But how does management still maintain visibility of what's going on and are active in that? So we don't need 5-6 layers of management. We don't need all these layers of systems between machines, and then going up to the SCADA layer, and then going up to the MES layer, and then going up to the ERP layer. If you think of the ISO 95 model, right, that was established around the 70s. We right now can have a much more collapsed model that doesn't skip any of those functions, but we can send data, publish, subscribe data, which you've talked about in some of your other podcasts, right, to many places. And this is where the power happens. One of the big powers of going digital is that when we were in paper, even though a lot of forms had those yellow copies, and we did a few things in parallel. For the most part, it was very sequential. The paper moved through the organization very sequentially, but data doesn't need to move that way. Data can be distributed out to many departments at the same time. And that is all part of the smart manufacturing concepts, that by getting that data to more people at the same time can do more things in parallel. It can be a much flatter real-time reaction to what is happening on the plant floor.
Okay, interesting. So another principle that is of interest is the scalable principle, with cloud and edge being the cloud and edge computing being the enablers. Can you describe that one to us?
Yeah, so scalability is very important. There's several dimensions to scalability. Let me start with it's hard to talk about it without interoperability, so which is another one of the concepts too. But let's try to address the computational part. In general, the idea of scalability is that as complexity increases, as we bring more machines connected, as we connect more of our divisions together in a big enterprise, as we connect the supply chain, that things don't get so complex that it also brings cost and the effort of maintaining these systems up exponentially. We want to at least maintain a linear relationship between how we're adding things and the cost and effort. But they tend to grow exponentially if there's not thought about that from the beginning. So cloud has been a big enabler of this for scalability, because I mean, really, it allows organizations to almost forget about, not even think about some of the scalability, right? I mean, in the background, the cloud provider can keep adding machines and stuff and infrastructure and scale their computing power. And sometimes we just take it for granted that this transaction keeps happening. I press the button and something happens there in a few seconds. And when it's delayed a little bit, I'm like, what?
Yeah.
Right. So we want that kind of performance in manufacturing. It's not, and we want to take advantage of all these methodologies. But to do that, we need to have systems designed more modular, right? More upgradable, because upgrades are very important. And that means that they cannot be so tightly integrated that complexity of integration that creates a fragility. And that's where the relationship to interoperability and openness is very important. So we need to, the way we connect things needs to be in an open, very API driven way, not instead of a very proprietary way. Okay, we'll get back to that. But cloud also, I just want to mention on cloud though, that we don't mean that everything needs to move to the cloud. Okay, so it means that you need to leverage cloud services and put them where they need to be. So it's really about looking at all these layers. Now, a lot of what we're doing on premise, we're close to the machine, we're calling edge computing. The way I think of edge is on premise with an intent to go to the cloud. Data has an intent to go to the cloud, then it's edge. If we never intend to send it to the cloud or something, then it's on premise, right? On premise. But once we have that intent, we're thinking about the edge as part of a bigger ecosystem, a landscape of IT system, which includes cloud. And there's ways to transition that without rip and replace and start the old factory. So and it's become so much more affordable with IoT sensors, with edge devices, with gateways. to connect things in the plant. That's all part of that scalability, the affordability of it. And actually, one of the missions of CESMII is that, remember I talked on the technology side, what are we doing is demonstrating through platforms, through integration methodologies, how a lot of these integrations can be designed to be more plug and play, how you can establish information models as you go along, so that the next time you are going to go connect something, you look at the library of information models and you leverage that instead of starting from scratch. That's part of starting to reduce that integration cost, which is part of that scalability, is that the next time you do it, it has to become cheaper than the first time you did it.
Oh, okay, that's awesome. Perhaps let's move on to the principle of interoperability, because interoperability is a big topic. I mean, in smart manufacturing. In fact, I would have been surprised if that had been left out as one of the core principles. And so, could you explain to us your idea of interoperable and open as far as smart manufacturing is concerned? And maybe, as you already alluded to, the information modeling aspect of it is crucial. So could you also talk about that?
Yeah. It's a very crucial point. Over the last like 5 years or something, there was a movement, or maybe it was a little more, but when data lakes came to bear, and the term big data lakes, there was a big movement to grab any data that you can get your hands on and put it into the data lake, and we can put data models on it later, on runtime. So don't worry about it. Just put data into the data lake and think about it later. Really, that has not panned out. That's panned out, and you hear people say, "Oh, we got so much data and we're not doing much with it." Right? I think Gartner has the numbers like 70% or over 50% for sure of the data collected wasn't even being used. So, we're really a proponent of information modeling, and that thought process behind information modeling happening a little more upfront. So really, you collect data for specific purposes. Is it to track performance? Is it to do machine monitoring for productivity reasons? Is it for future diagnostics and troubleshooting? So with these ideas in mind, you are collecting data. And then since you have that idea in mind, you're collecting data about assets, you're collecting data about your manufacturing processes, and there should be certain information models that bring that data and the context together and kind of sets it up for analysis in a way that you can create analytical models that go after certain information models in a very repeatable, reusable way. So if every time I'm going to do an analysis about a CNC process, about a cement casting process, there's certain variables there we're looking for. I can generalize the algorithms that optimize the process, and the algorithm is looking for certain data, and I can apply then those real-time methodologies as they happen, and I can reuse them somewhere else. The information model becomes a guideline for somebody else. Hey, if you organize your data this way, by the way, I have a whole library of things you can use against that information model. So those are some of the concepts that we promote as part of interoperability. Separate the information modeling from the application, so that they're more like a contract of how they're going to exchange data. It's established up front, and then make that open. So
Yeah.
there are vendors that have ways to do this within their suite of products, between their machine and tightly integrated software and stuff like that. But that does vendor lock-in, right? And that creates another constraint. And things are moving so fast. So part of what we want to do to future-proof our system is that we need to promote open ways, more standard ways to do things. So we're a big promoter. We're working with OPC Foundation, with many other partners, MT Connect, and with VDMA in Germany, in those efforts with the asset library. So that all these libraries become open and available. And we need all the vendors to support it. I mean, we just had Rockwell join CESMII. That's great. And we believe that to support the speed of innovation and manufacturing, interoperability is very key for the future.
Oh yeah, absolutely. I totally agree. Such projects really need the backing of the corporate sector. And one of the projects that I'm really interested in that you are a part of is the OPC Cloud Library. But I think that's really a very, very useful platform to have.
Oh yeah, definitely. Yeah. And we're something, if people don't look at standards, you can implement a lot of these technologies and do it just looking inside and say, everybody can, I'll create my own information model. I'm not going to wait for the standard or participate in standard, but looking at yourself as an island, it's a silo itself. We believe that it's not the best way. By creating an ecosystem where we are all exchanging data, best practices, crowdsourcing things, really you expand your talent pool. Because you're tapping into this whole network of people, like all these speakers you bring on the show, right?
Yeah.
They're all some of the smartest brains in the industry, right? But they're not all within your company. They might be in the next company, the other company, but when you work in open libraries, forums, consortia, in groups like OPC Foundation, VDMA in Germany, we're tapping into all of the knowledge in Europe. You're basically leveraging all the knowledge of that ecosystem. Now, there's a way to do it that doesn't slow you down. So a lot of what we promote is also object-oriented, extendable methods. If you want to learn more about this, by the way, CESMII is a great place. I'll say it again at the end, but to join us, follow us, and we can point you to the right places. But OPC Library is one of the places where we're trying to accumulate knowledge, and the library at CESMII, at OPC, VDMA, we're connecting all these libraries so they all start becoming part of a broader library. So the idea is when you are going to do an information model on a certain kind of machine, on a heat tunnel, on a conveyor belt, and a robot, first go to the library, look. So what have other people done? You might find 1 or 2 models there, and then look at those as a starting point. Pick something close and then extend that. And by the way, if you extend it yourself, I mean, you might think that's part of your secret sauce if you do, but if you don't, contribute your extension back, make it available, and then it keeps getting better and better. So those are some of the ideas that we're promoting.
Oh yeah, absolutely. It's interesting. Now, maybe as a follow-up to the topic of interoperability, I would like to get your take on what the role of ISA 95 is in smart manufacturing.
Yeah. Well, ISA 95, I mentioned it a little bit, and a lot of folks view it as a very hierarchical structured way to pass information. ISA 95 actually started way back as the SIM model, the Purdue model, the SIM wheel. A lot of these core concepts of how manufacturing functions are divided and exchange data have been matured through these standards and have become part of standards like ISO 95. So I like to refer back to it all the time from a functional point of view, mostly. Okay. And it's important because if we're going to establish how things link together, create information models, let's look at best practices that have been around for many years. However, don't look at it as a constraint, that it has to go those layers. They had like 5 layers of systems. Also part of it, but I like to look more of the ISO 95. I think it's called the part 5 or something, but where all the functional blocks are, like scheduling, inventory control, data collection, quality management, and look at how those exchange data. I think that part is very interesting, and also they talk about how to bring together resource models, asset models, and bring in people into that whole process model. So a lot of times some people are very focused on assets and modeling assets and asset-centric, machine-centric modeling and solving problems around machines and predictive modeling, predictive maintenance and things like that. But there is so much more to gain from looking at how assets become part of a process model in an ISO 95 type of environment, and look at doing that optimization at that level, and then taking it even further, that whole factory and plant as a node in a supply network. And let's look at optimizing that, right? And that's where you start applying those digital lean concepts and leaning out the whole business process, eliminating waste, identifying bottlenecks, all at the enterprise level.
So another one of the principles that you've outlined is the proactive and semi-autonomous principle. Can you describe what that looks like, and perhaps also provide some examples of some techniques there?
Yeah. So why are we collecting data? So this is actually one of those key differentiators here. Why are we collecting all this data and what are we doing with it? Is to really take action on it. Okay. So one of the things we talk about is that we have to go beyond just thinking of data as a part of collecting data and putting it on a dashboard, and just collecting it for metrics. That's a very basic step, but that's not smart manufacturing. To make it really leap into smart, we have to look at turning that data into information and putting it into analytics, and intelligence, and trying to automate the routine decisions, and that's not where people aren't doing a big contribution, because we can automate this type of optimization simple decision gates. That should be automated. And we should leave the human for the non-routine handling. But what we also have to think of that a lot of these things cannot be fully automated either. And the idea that AI is going to take over and stuff, AI is going to be more artificial intelligence, more of a assistant, really. We're going to automate as many things as we can automate. Those start becoming routine, but there will always be special situations that come up. This is a complex environment, a lot of variables, and it's better to think of it in how do we bring the attention of the decision makers to the non-routine situations that come up, right? And so that's a very important aspect. And so something we talk about is the data sensing, analysis, and process control loop at the heart of smart manufacturing. So you capture data, you contextualize data, you apply analytics to it, and optimization algorithms and methods, and you also use it to optimize your process control. So you have to make the adjustments back, turn those knobs automatically or through people. What are you changing? The action you're taking, that's the proactive part of this, that you're doing all this so you can take actions and keep improving, fine-tuning, or just maintaining the process within specs. But you could also be improving the process and the whole, eliminating waste, improving energy consumption, improving the use of resources in general. And that's where the sustainable manufacturing part comes in play, that with all this data, we can make better decisions about how we use resources and optimize the use of resources. And all of that is eventually contributing to the environment too.
Oh, okay, interesting. I guess this will be a nice segue into the other one of your principles, which is the sustainable and energy efficient principle. Can you explain that one to us in more detail, and perhaps provide some methodologies around that?
Yeah, sure. So there's some very specific examples of how intelligence, AI-based machine learning techniques are being applied in manufacturing, right? And all the way from safety cautions that are automated for the plant, a lot of predictive maintenance on machines to lower downtime, vision systems that might improve quality, augmented reality to augment the worker. A lot of the are based on AI techniques being used, but one of them is this optimization methodologies. We have great examples of working with energy intensive industries, or with cement industry, with chemical processing industry, with food industry, where in our project they have developed the information models and the machine learning algorithms to apply to certain problems to make huge energy reductions in specific processes, and do it in a way that is reusable and we can scale it into using that whole industry. So this is a very important part of how we become more sustainable manufacturing, by not just optimizing that process at that one manufacturer, which is very important for that manufacturer, but the reason we're a national institute is that we're trying to get these practices out to industry, learn through 1-2 implementations in a few manufacturers, but to then package this knowledge, put it in the library, make it available to industry, so that we are really then applying those energy savings, those productivity improvements to whole industries, you know. So we have great examples of that. And a lot of that is facilitated by standardizing some of the reporting, like carbon footprint reporting, derived from data collected from machines and processes. We can, you know, just parts and material traceability is very important, because where is all that? Where are we losing material? Where are we creating scrap? What kind of yields do we have in different processes in that material chain? When there's all kinds of energy and carbon footprint along the way, all the way from raw materials to that package and the shelf of your grocery store. So looking at that whole process, eliminating waste along that process, there's all this side benefit of eliminating wasted energy, wasted resources, and improving the footprint. And then we can also promote more efficient ways to to use more reusable, renewable energy. A lot of the Department of Energy efforts are along those lines. So we welcome you to follow a lot of the efforts from CESMII and the Department of Energy in how we're helping manufacturers become more energy efficient, more improve their carbon footprint also.
Awesome. I mean, there's a lot to talk about here, because I mean, even like as you mentioned, a lot of these principles, they are interrelated to some degree. So before we close this session, is there anything that you think we might have left out that you'd like us to point out to the audience as far as the principles are concerned?
Well, I think we didn't talk much about the supply chain, mentioned it a little bit, and security. One of the principles is that this all has to be done in a very secure way, but that in itself can take up a 45-minute slot, and I'm sure you will have some other expert online to talk about that. Just reassure folks that there are ways to secure data, that security shouldn't be an excuse of not connecting things, of not sharing information, that there's ways to do it in a way. You don't have to make all your data public. You don't have to be worried about losing intellectual property. There's ways to do this and maintain your truly important information to yourself and still increase the level of transparency in the supply chain. So I encourage you to go to CESMII, CESMII.org, to get more information about a lot of these practices. We're continuously participating in conferences, providing lectures. There's a lot of resources available for you. So take advantage of the tools. We're a national institute. We're making tools available, resources available, education available. There's a list of educational resources and partners with education programs on our website. So I just welcome you to join CESMII, become part of the ecosystem here that's helping with these concepts, helping get them out to the masses, helping small, medium manufacturers. If you're a consultant, helping small, medium manufacturers, we have tools for you to help get these practices into the hands of small, medium manufacturers. There are a lot that you can do at a much lower cost than you could do before. So I just want folks to be reassured that these methodologies are accessible to more and more manufacturers every day.
Okay, awesome. Thank you so much. So yeah, we are going to be providing links to all of those projects and to the CESMII website in the description below, and also to the article, which I would encourage a lot of our readers to go out and read, as it is packed with a lot of insightful information as far as smart manufacturing is concerned. So that brings us to the end of this session. Conrad, thank you so much for coming through to this show.
Thank you. And thank you for having me. And thank you for sharing all the information you do through your podcast. Thank you.
Thank you.